question 36 says, over what interval is the function decreasing? Well, increasing and decreasing change at the vertex. So if you find 1, 2, 3, this occurs at 3, x equals 3. Increasing, well, it changes over. So something is happening between negative infinity and 3, and then something else is happening between 3 and infinity. I can see that it's going up, so it's increasing until that point, and then it changes over, and then it becomes decreasing. So decreasing is 3 to infinity. This is kind of a 50-50 guess. It's just either negative infinity to that number, or that number to infinity. It's just one or the other. Okay, over which interval is the function negative? Well, we've been doing the number line in class, and we look at these values. So that's 0, and that's, looks like 1, 2, 3, 4, 5, 6. I wrote kind of small, the 6 there. So if I was doing negative or positive, I would just highlight what happens. So it changes over at the 0. Well, negative is below the axis, so that's going to be open circle to the left. Also this direction, with an arrow on the end. So open circle to the right. I didn't actually tell you less than or equal to, so negative things occur below the axis, because on the axis it equals to 0. And positive things occur above the axis. If I were doing positive, it would be open circle between 0 and 6. But anyway, it wants to know what the interval is. So I graphed it so it would make it easier. But my interval is just, what is this interval notation? Well, that's negative infinity to 0. Parentheses, because it's open. And or, so union, 6 to infinity. So that's both of those answers I pushed together. And then lastly, over what interval is the function increasing and positive? Well, positive is above the axis, increasing only occurs to 3, so it's actually just this section here. I'm just going to shade it in. So between, well, we said it was negative from 0 down, so it must be from above 0 as well. And it starts decreasing at 3, so it must stop decreasing and stay increasing at 3. So it's only increasing and positive on this little section here, between 0 and 3. Okay, question number 37 is asking us to compare a function that they just gave us, that's function p, to a function that is graphed, which is function q. And if I read through the multiple choice question, so I know what it's asking about the maximum of either, and it talks about the axis symmetry of either. Well, in order to find the maximum and the AOS, I need to find the vertex. So those both are contained in the vertex. So this vertex is pretty easy. This vertex is 3, 2. So function, oh, it's not a G, it's a Q. Anyway, function Q has a vertex at 3, 2. Then I'm going to find the vertex of negative 3x minus 2x squared plus 5. Also note that this is not in standard form. So on the key, when I was doing the math by hand, I did negative b over 2a to find your vertex, etc. So I would make sure I wrote that in standard form. But because I'm plugging it in the calculator, just plug it in as it appears. I want to find my vertex. So I'm going to graph it. There it is. How do I find my vertex? Second trace. It's a maximum. Left bound, enter. Right bound, enter, enter. Okay, so my vertex is 0.75, 6.125. So the vertex for P is 0.75, 6.125. And that's going to give us all we need to know to answer every question. So function Q has a larger maximum versus function P, which has a larger maximum. Well, function P's maximum is 6.125, and function Q's max is at 2. So clearly function Q does not have a larger max, and function P has a larger max. So which statement correctly compares these? Well, actually, we're done. We could stop here, but I'm going to go ahead and prove why the other ones are not true. The AOS for Q is 2 units to the right. Well, the AOS for P is 0.75, and the AOS for Q is 3. Well, 0.75 and 3 are not 2 units apart. They're also not 4 units apart. So neither of those work. They're actually 2.25 units away. So neither of those work, but we already found the correct answer right off the bat, just by comparing the maximums. For question 38, again, we're still in chapter 13, so you should be able to solve it by the calculator. I'm going to show you how to do that in just a second, but I did want to go ahead and show you on the answer key what I did. If you are solving it by hand, The question says that I have a function, which is a little bit off the screen, but here's my function. And then it asks me determine the times when the ball is higher than 6 feet. So to do this by hand, I would set the height equal to 6, and I would solve like normal. So get it equal to 0, quadratic formula, you get 0.18, and 0.70. This graph is a negative 16t squared, so I know it's going to be an upside down graph, which means if I'm looking at the graph, it's going to be wherever it's at, 0.18 and 0.70, whatever this graph looks like. So once the times of the ball is higher, so it's higher after 0.18 and before 0.70, and then below those points it's lower, or after those points it's lower. So my answer is just 0.18 and 0.70. So if you did it by hand, that's how you get the answers. But I mean, I had to do a lot of work. I had to do the quadratic and then solve and then graph. It's much easier, since I have a calculator, to just go plug in your function. Make sure you plug it in correctly. So 14x plus 4. Okay, go ahead and graph it. I can see the graph there. I want to know when the ball is higher than 6 feet. So I'm going to go to y equals, and that's a height. So I'm going to put in 6 for y equals. I'm going to graph it. This guy's actually kind of small, so you got to be a little careful on this one. I want to find those times. So second trace, intersect, first curve, enter, second curve, enter, guess. It's actually already closer to that left answer, so I'm just going to press enter. That's going to give me 0.179, which is that 0.18 right there. So there's that first value. Then I'm going to find that second value, which is very, very close. I'm going to do the second trace, intersect again. First curve, press enter, second curve, press enter. And then the guess, I'm going to go to the right a little bit, just so the calculator knows I'm doing the right one. And I'm going to get 0.695, which is 0.7. And if you just look at the graph, I can see that it's above for just a little bit. So when it is higher than 6, it is going to be between those 2 points, so between 0.18 and 0.7, because it was higher than. On the other question above, on question number 35, I think, yep, 35, it says at what times will the ball be 3 feet above the ground? So that one we just set it equal to 3 and solved and found those values, and it couldn't have been the negative, and we did that on the calculator. But when it is 3 feet above, it's just the answer. When it is higher or less than or something like that, it's going to be some interval there. Question 30 says, consider this function. What interval are the y values greater than or equal to 0? Again, by hand, you could set it equal to 0, find the zeros, and graph it. I did that on the key, so you can look at that if you want to. Otherwise, use your calculator. I went ahead and plugged in 4x squared minus 4x minus 3. I'm going to go ahead and graph that guy. I want to know when this function is above 0. So I'm going to go ahead and I've got to find my zeros first. So I'm going to second trace. I'm going to go down to 0. I'm going to go left bound. I'm trying to find this 0. Left bound, enter, right bound, enter, guess. Okay, so it's got a 0 at, I'm going to go ahead and sketch it just because it might help, at negative 0.5. So negative 0.5. I want to find my other 0, so I'm going to go second trace, go down to 0. Trying to find this 0. So left bound, I already am left bound. Right bound, I've got to press the right arrow key until I'm to the right of that answer. Press enter. Guess, press enter. 1.5. 1.5. And then we don't really care exactly how it looks, but we just care close enough. That looks like that. Consider the function this. What interval is f of x greater than or equal to 0? Well, that's going to be anything, and I should have crossed that there, anything above the axis. So if I were doing the number line, it'd be on either side, but I'm going to do, it's going to be negative infinity to negative 0.5, and this guy has the equal to, so he's going to be a bracket, or 1.5 infinity. And so that's very messy. But if it's above 0, it's going to be to the left and to the right. If I were asking below 0, I would have bracket negative 0.5 to 1.5 bracket. All right, number 40, consider this function, graph the range of values of x on a number line. Okay, so I'm going to go ahead and draw myself a number line here. Boom, boom, boom. For which f of x is greater than or equal to, just greater than negative 4. If you were to solve this by hand, you would plug in negative 4 here, set it equal to 0, solve, and then just do a sketch. I know this guy is negative, so he's going to be upside down. So I know that he's going to be greater than negative 4 at some values between that. So if you were to do it by hand, you would do the math equal to negative 4, and it'd be in between those two values. But I have a calculator. Might as well use it. So I've already gone ahead and plugged in negative x squared plus 2x plus 4, and I want it to be crossing over that negative 4 line, which is a y value. So I'm going to go down to the next one and put negative 4, and I'm going to graph. So I'm going to graph my first function and my second function. I want to know when this is greater than negative 4. Well, I got to know when it equals negative 4 first. So I'm going to do my second trace. I'm going to go down to intersect, first curve enter, second curve enter, guess. I'm just going to get close enough to it. Negative 2. So negative 2 is on my number line. That is the point when it is equal to negative 4. So here it's below negative 4, here it's above negative 4. I'm going to do the exact same thing on the other side for this guy. So second trace, intersect, first curve enter, second curve enter. You do have to tell the calculator to go over here and guess on this answer here. So just get close enough to it. And that guy's a 4. So this other number over here is 4. So it wants the x values in which my graph is above negative 4. So I want all the x values between here and here, which is going to be everything between negative 2 and 4. Not inclusive though, because there's no line there. So it's going to be open circle between negative 2 and open circle between 4, and boom. If it asks for the interval, I would say negative 2, 4. That would be the interval notation. Question 41 is asking which function best models the data in the table. So I've got to figure out what this data is. I can look at my multiple choice answers and I can see that I have a linear, quadratic, and exponential. So if I just see what this is, it's probably going to eliminate at least half the answers. So checking for exponential is really easy. Can you find something that multiplies 29 by 29 and gives you 66? And then the same thing gives you 101 and then 134. To check that, oops, I've already started the problem here. To check that, just work your way backwards. 194 divided by 165. So the factor must be that. Okay. 165 divided by 134. That is different. As soon as I don't have the same division, then this guy is not exponential. He's not multiplication. So this guy's already, boom, not the right answer. Okay. Next, linear. Just see how these guys grow. So this guy's adding 37. This guy's adding 35, adding 33, adding 31, and adding 29. As soon as it's not the same value added repeatedly, it is not linear. So it cannot be that value. So it's going to either be quadratic. Well, it's going to be quadratic. We just got to figure out which one. I don't actually have to go any further to prove this, but I am going to go ahead and just prove it is quadratic. This minus is 2, minus is 2, minus is 2, and minus is 2. So that does make it quadratic because that negative 2 across the board is the same. But it's already quadratic. I can see by both functions. I have a calculator. I would go ahead and plug it in. So I went ahead and already plugged in option B into the calculator. And I'm just going to, you don't actually need to graph it. I'm just going to go to the table. So second graph to go to the table and compare. So 129 and 266 and 3 101 and 4 134. All right, that's the answer. I don't need to do anything else. That table matches perfectly. So therefore this one should not match perfectly if I were to plug it in. So I'm done. If this one did not match, I would cross it out and it should be this answer, but I want to make 100, so I would still plug this in y equals and I would still check that answer.